Okay,
Yes, we can.
perfect. And it looks like the recording started. Perfect.
Yeah.
Hello, everyone. My name is Mitch Shepard. As Hilde mentioned, I'm a product manager for Marklogic Server. More recent or prior to working with the server, I was a product manager for some of our developer experience tools and connectors in Fast Track. I've been a Progress for about just under 4 years now, and excited to talk to you about all the exciting things that are coming with Marklogic 12. So with that, we're going to jump into it. The first thing I want to really cover is some of the release highlights. And Marklogic 12 is built to help organizations move faster, scale smarter, and really deliver a more trustworthy AI and analytics experience. So we're going to walk through 5 key benefits for this release. The first one being maximize GenAI retrieval accuracy. So we've added native vector search to complement our existing full text, semantic, and metadata search. This hybrid approach ensures that GenAI systems can retrieve the most relevant and trustworthy information, which is really critical for enterprise-grade RAG solutions. Second, we've got answering business questions faster. We are introducing virtual views, which let you create relational style views on the fly without necessarily needing to reindex or adding storage overhead. We'll go into each of these capabilities in the upcoming slides, but what this means is that teams can explore data and generate insights in real time, which ultimately accelerates decision making and helps reduce IT bottlenecks. We are working to meet modern application demands. So with dynamic host management, our customers can now scale their clusters up or down based on demand, and this ensures higher performance during peak usage while keeping infrastructure costs under control. We are modernizing platform support. So we've improved our platform support to include Red Hat 9, Amazon Linux 2023, Windows support 2022. We've introduced a rootless Docker image, and all of this really gives you flexibility to modernize your stack and deploy in the environments that best fit your strategy. Last, hardened security. Security is always a top priority for us, and so with support of the latest encryption standards and FIPS 140-3 readiness, Marklogic 12 will help you and our customers meet today's compliance and risk management requirements with confidence. So together, all of these enhancements really make Marklogic 12 a powerful foundation for building intelligent, scalable, secure, data-driven applications. And with that, we're going to kind of dive into more around maximizing GenAI accuracy and then the various features that we release. A primary step on our customers' AI journey is really determining how are they going to leverage GenAI. And leveraging GenAI is all about being able to find the most relevant data in response to a question. So this is nothing new for our customers, but the techniques and tools that are being applied are new and promise really significant gains, but also pose a handful of challenges. So I think we all know the common adage, garbage in, garbage out. Our goal with Marklogic 12 will be to ultimately build on the already powerful search capabilities and provide our customers with the most flexible platform to be able to implement the right RAG architecture needed to meet their business needs. And this means that we need to be able to find the most relevant data, implement various combinations of indexing and retrieval techniques for the different RAG approaches, but do this all in one platform. And that's where a lot of our efforts have been focused with this release. So in Marklogic 12, and for those of you that have played around with some of our EAs, we're introducing native vector search. This is an essential capability for providing like next generation AI applications. So this feature is going to allow you to store vector embeddings directly alongside your data in JSON or XML, which is going to enable large-scale similarity searches across the vast volumes of unstructured content. Native vector search capabilities in Marklogic is going to allow our customers to deliver answers to queries based on similarity search that will improve the GenAI retrieval accuracy. But developers will also be able to use the vector operations capabilities in Marklogic by representing whole documents or even just parts of documents as vectors, which can then be searched against. So these vector operations can be combined with our existing techniques, such as structured metadata, full text, graph, geospatial, really any of those data types to implement the most flexible multi-model, we're going to call it hybrid RAG techniques. And there are a handful of benefits from being able to store these embeddings in documents in either JSON or XML to performing semantic searches on extremely large volumes of data. But there are also a handful of use cases as well, right? So like, why does this matter? These vector operations can be combined as we talked about to create the hybrid RAG search, because traditional keyword searches often fall short when you're trying to find semantically similar content. So especially in like our large unstructured data sets, vector search really bridges that gap. For example, let's say a user asks a question in natural language. Vector search can retrieve documents that are conceptually related, even if they don't share the same keywords. So you've got RAG use cases that really help large language models pull in the most relevant background information for better answers, recommendation systems that improve suggestions by understanding what users actually like, not just what they've clicked, similarity searches that make it easy to surface related content even when the wording is completely different, and risk management. So help spot early warning signs by connecting patterns across large volumes of unstructured data. And because Marklogic integrates vector search with the full text search via our Optic API, you really get the best of both worlds. You get semantic relevance, precise filtering, really delivering the highest quality results for your AI and search applications. Now let's talk about a couple algorithms that we've implemented to help with that precise filtering. The first is BM25 that'll be available in Marklogic 12, which is an industry standard relevance ranking technique, and allows for different weighting to be applied based on document length beyond what we currently support for relevant ranking. This allows customers to really tune your full text search relevance. You can tune that relevance ranking even more, so you can leverage your existing search indexes without having to necessarily vectorize all of your content up front, which can be costly. But then you can combine your vector search and BM25 to achieve cost-efficient search performance for, say, Gen AI responses. So you get full text search with BM25 scoring. It's really an inexpensive method to rapidly sift through billions of documents. We're also implementing the graph shortest path algorithm. So graph shortest path is an algorithm that's commonly used in, say, routing use cases such as navigation or network analysis. It helps you really kind of find the shortest path between two nodes in a graph, or find the paths to all the nodes with a certain number of hops from a node. So this feature wasn't originally envisioned as part of our machine learning or AI roadmap, but as we're seeing and as the market's evolving, any and all techniques are being explored to be able to best identify the most relevant information to help feed LLMs for analysis or summarization. So the shortest path, this algorithm is going to add yet another tool to our platform that allows users to leverage and implement different RAG techniques. A super exciting feature that's coming out is virtual views. So we're building on our template-driven extraction or TDEs by introducing vector views. And this gives you more flexibility in how you project data from a document into rows and columns. Unlike traditional TDs, virtual views don't require materialization at ingestion. So instead, you're extracting data at query time. And this means that you can create views on the fly. So that means no reindexing, no storage overhead, and quicker query execution. But it's also ideal for running long running or ad hoc analytics on large databases. And because virtual views can be joined and with materialized views, you also are getting the best of both worlds here, flexibility and performance. The query engine automatically is going to optimize and use materialized columns, and the universal index to minimize the number of documents that you necessarily need to retrieve to resolve a query. Let's take a look at some of the use cases. So where do virtual views really shine? Identified three main ones: large scale and ad hoc analytics. Virtual views are perfect for running complex queries across large data sets. So especially when you don't want to pay the price in disk or memory, since these don't require materialization, you can analyze data on demand without adding storage overhead. This gives you flexibility to balance performance with infrastructure efficiency. We've got data exploration and discovery. So if you need to test a new idea or prototype a report, virtual views is going to let you create relational style views on the fly. So no reindexing needed, and it makes it easy to explore your data in new ways without waiting on IT or changing an ingestion pipeline. And then last is data tiers. So you can also combine virtual views with super and sub databases to support tiered storage strategies. So this means that you can keep like your old data in the cheaper storage and still query it alongside hot data without moving anything around. Really adds a lot of flexibility. In Marklogic 12, we're introducing dynamic hosts, which allow you to add or remove evaluator hosts, eNodes on demand, which means your cluster can grow to handle spikes in application usage or shrink down when demand drops. And this gives you flexibility to scale out your queries when needed without necessarily overcommitting compute resources. To enable this, we've introduced token-based cluster join authentication, and this is going to simplify and secure the process of adding new hosts to a cluster. So it's a faster, safer way to expand your environment. And because you're only running the compute that you actually need, you can also optimize costs, especially in the cloud or hybrid deployments where resource efficiency directly impacts your bottom line. So ultimately, it gives you more control to scale when you need to. We've added a bunch of support for the latest OS technology. So you'll see Red Hat 9, Amazon Linux 2023, and Windows 2022. A rootless Docker image is now available. And one thing to note is that Red Hat 7 support is being removed from Marklogic 12. Also have some major library upgrades. To support the security posture, right, you've got OpenSSL. It'll be supported with TLS 1.3 and FIPS 140-3. Our JavaScript engine, we've upgraded the V8 engine to version 12.4 and a lot of updates to the JavaScript language features. This is more modernization efforts. Similarly, document filters. So if your customers are using our converters packages, we've got document converters and document filters. The document filters is being enhanced. It's being enhanced to allow you to do more text extraction for thousands of binary formats. It is good to note that the document converters is being removed from Marklogic. And with that, so this is kind of the Marklogic overview. I'm going to pass it over to James Kerr, who's going to give us a deep dive into what this means or what this looks like in more detail. So with that, James, I'll pass it over to you.
Great, thanks, Mitch. All right. So yeah, I'm going to jump in and talk in a little more depth about all of the features that Mitch just went over. Not quite all of them, but a lot of them. So let's dig into vector search a little bit. So vector embeddings, for those of you who've been working with generative AI and RAG systems, this just shouldn't be anything new, but vector embeddings are essentially high dimension floating point vectors or lists of numbers, right? Just a big array of numbers. And those arrays of numbers are generated by a vector classifier model, which LLMs include the vector classifier models. And those models are able to take content as input and then embed the meaning from that content into the numbers in the vector. So, in the past, we might have called semantic search might have been, using a knowledge graph and using semantics with Sparkle queries, et cetera. Vectors give us another way of sort of embedding meaning into data that's extracted from content. And the vector search uses a couple of different metrics to determine similarity between vectors. So the basic concept is like two vectors extracted from content that has similar meaning or similar topics. Those vectors will be closer together in their angle, as well as potentially their actual distance, right? So Euclidean and cosine distance are two measures that are used to determine similarity between the vectors. In Marklogic 12, we introduce really powerful capabilities to combine all of our rich querying mechanisms that we've been building applications with for years, combining those with vector, really leveraging pure true multi-model querying to be able to produce hybrid RAG solutions using like all kinds of different types of queries that you can do in Marklogic. So if you sort of go from the simplest to the more complex, just starting off, you can of course just do pure vector search. And I'm going to go through all of this in Query Console. I'll show you some examples. But pure vector search, you can do a search with an incoming vector and find the similar vectors ordering by the cosine distance, and that's uses an approximate nearest neighbor index to make it fast. Of course, you can then do pure vector search with metadata or content filter queries, right? So being able to combine to limit the documents, say by collection or by fields in your metadata within your documents. And then, of course, being able to combine all of that with our existing capabilities, text searches, geo searches, semantic knowledge graph queries, and being able to re-rank those query results by vectors. And this is something we presented actually, almost a year ago in our first early access for Marklogic 12. The concept of being able to query using our existing indexing and multi-model queries, and then re-rank by vector similarity. In Marklogic 12, that we now introduce the capability to have indexed vector similarity, so that you can run multi-model queries and vector search queries and essentially join them together. So you might there might be some documents you find with say a full text query, or like what you might call a sparse vector query, and there might be documents that also match your vector query, or are close rather in your vector query, that don't match your text query, right? And so you want to be able to find a combination of those documents. And so conceptually, documents that match both your sparse vector queries, your lexical or text queries, and also are close together from a vector perspective, those are going to be the most relevant documents. And with Marklogic 12 and the Optic API, you're able to run those types of queries. I'm going to go through I'm going to jump back to vectors when I switch over to the demos, but I want to go over virtual views real quick because in the demos, I'm going to actually try to cover both of those topics. So virtual views, as Mitch mentioned, are a new way of defining your template-driven extraction views in Marklogic 12. And all of this is all leveraged by using the Marklogic Optic API. So just a quick refresher on the Optic API. It's our multi-model query language. This is where we're doing all of our main innovation on the query language side. We've been focused on enhancing the Optic API, and so vector search is available via the Optic API, and you're able to combine the vector search with all of the other query models through the Optic API, and that's where we get the real powerful multi-model querying capability. Combining that with template-driven extraction, where you have a declarative way of projecting views and graphs or triples out of JSON XML documents. And of course, this tooling is available through all of our client and server-side APIs. Just a real quick refresher on TDEs. TDEs, you can extract triples, right? You have documents, you have a declarative template, and then you can use that template to project out a knowledge graph in the form of RDF triples. You can also take that document and extract out rows, right? So you can create a relational view on top of your hierarchical XML or JSON documents. So normally, you might have a document that is, this is a very simplistic example here, right? But we have property name, SKU, title, price, and those might map into a view with columns, SKU, title, price. I mean, typically you're not projecting all of the properties out. You're selecting only the ones that you want to put into your view. And then, of course, the values are then projected into the values in the rows and columns. So in virtual views, this all works exactly the same, except that instead of happening at ingestion time, a virtual column is projected out at query time. A virtual view can be defined at the view level, right? So you can mark a whole view as virtual, or you can mark individual columns as virtual. And as Mitch mentioned, one of the real powerful capability here is being able to combine virtual columns and non-virtual or materialized columns to produce a view that can meet your various query demands, right? So you can think of it much like you have thought about it in the past with the relational database tables, where you might start off with a table that doesn't have any indexes. You're doing full table scans to resolve any queries, but you realize that you need to order on a certain column, or you always need to match on a primary key. So you create, based on your query needs and what parts of your queries are going to be selective, you define which columns you want to have indexes on. And with virtual views, this now gives you a similar capability within Marklogic. And point 5 here really is part of the secret sauce of the whole feature, is that under the covers, the query engine is being rather intelligent to try to leverage all of the indexes that are available to actually resolve the query. So even if you have a virtual column, or if you define a column as virtual, the query engine will also try to leverage the universal index. It'll try to leverage range indexes. where to actually reduce the working set of documents that have to be scanned to produce your final query results. So once again, leveraging the best of both worlds, all of our search and rich indexing capabilities built into the universal index with the relational engine in Optic. One note on transitioning from Marklogic 11, right? So you might be saying, oh yeah, great, I want to take advantage of this, but in Marklogic 11, I have created a view. I have a bunch of views. They have 10 columns in them. And now I want to expand that. I want to add new virtual columns in Marklogic 12. So because we've had to change quite a bit of the underlying mechanics, if you take an existing view from Marklogic 11 and you add virtual columns to it, it will trigger a reindex. But there's a little trick that you can use to sort of transition from 11 to 12, which is that you can create new views, which are virtual, and then you can join those together with your existing Marklogic 11 sort of materialized views. And the performance is basically the same. It's all the same sort of construct under the covers, but because of the way that we define the actual rows in the index in Marklogic 12, if you add new virtual columns into the existing views, they have to reindex. But leveraging this trick where creating a new view, which is a join of the old views and the new virtual columns, you're able to sort of transition from your existing virtual views, your existing materialized views, and leverage the virtual columns as well. So with that, I'm going to switch over to a little demonstration, and I will pray to the demo gods here because our IT decided to update our VPN client today as well. So hopefully everything stays connected. So I have a query console here that I've loaded up some data. This is about 2 million documents of Wikipedia data. It's just been run through a BERT model for embedding. So if I just take a look at the data, I have some content. It has a title and a chunk of content, and then there's an embedding that's stored along with the document. So that embedding represents this text. So if I want to run a basic vector query, I've taken a question, and this question is what birds are in the same family as herons. I took this question and I also ran it through that same embedding model. That gave me this vector, right? So this is all if you're not familiar with the RAG processes, this is all the things that are going on under the covers when you are like working with a chatbot and you type in a question, right? All the mechanics under the covers are taking that question, generating a vector, and then finding the content that is relevant to that question. So I can use the ANN top K function to do my vector query. So this is the main function that's added in Marklogic 12 that allows us to do vector similarity queries. So I can I pass in the query vector, and then I want to put the output into a column called distance, and I can pass in some options. I'm not going to go into much detail on this, but there are a number of tuning options that you can use. One of them that is most intuitive is the max distance. So if I wanted to make sure that if I don't have any vectors within a certain distance of my question vector, I don't want to get any results back, right? This is similar to kind of a geospatial radius query, right? I can specify that max distance. And so if I run this, I get back get back my list of documents ordered by the distance, starting with the closest and going out to 100 items. Yeah. As I said, ordered by closest to furthest. Next, if I want to combine this with a metadata filter, or in this case, I'm using a date column, and I want to find only content within a certain month, I can use that. So this works as expected. But as we'll notice, this view I'm only getting back this ID, the URI, the date, and the distance. But in my documents, I had other things like the title and the content. But I didn't add that to my view. So what do? I'm gonna create a new view. So this view here has the ID column, the URI, the date, the embedding column. So these are the ones that I already have. I'm going to now add in two new columns rather, the title and the text. And these columns are marked as virtual. So when I run this is going to insert this new view. Oops, sorry. And if I pop back over to my database status, this is where we want to see, yeah. So we can see the database is not reindexing, right? So I inserted a new view with new columns. Normally, in Marklogic 11, if you were to do that, it would cause a reindex. It's going to have to reindex all of the content that matches your template. So, yeah, the database is not reindexing, which is nice. So if I go back and I add in a couple of new columns, I add in the title column and the text column. Those are my virtual columns. Oops, sorry. And so now when I run the query, I can get back the title and the text columns from my view. And those are virtual columns. So what's happening is it's identifying the top 100 documents by vector distance, and then fetching those 100 documents in parallel on the data nodes, and then projecting out the title and the text from the documents on the fly to produce the results. So now we get into the real power of this, is being able to combine the different types of queries. Just to keep it pretty simple, I am just doing two types of queries here. I have my same question, right? What birds are in the same family as herons? That produced my vector. I'm not going to take that question and I'm just going to tokenize it, make it into a bag of words, right? So this is just a simple lexical query, just an OR query, find all documents that have those words in it, right? So in the Optic API, I'm going to define two data accessors. The first one is from my wiki chunks view that I defined, right? So this is my view that I just showed you and that we added the virtual columns to. I'm also going to use a data accessor called from search docs. So from search docs, we'll take the CPS query, the word query, and find all of the documents that match that word query. So for both of these, I have different sort of limits that I'm going to apply. For the vector query, I'm going to find the top 100. For the word query, I'm going to find the top 1,000. And then, so using the Optic API, I can start with the search. I can limit that to the top 1,000. I can then do a full outer join between the two result sets, right? So now I have some documents that came from the search, some documents that came from the vector, right? The top 100 closest vector documents. And I can do a join between those. What that means, though, is I might have some documents that are in the search side, but are not in the top 100 vectors, and also vice versa. I might have the top 100 matching documents according to vector distance, but those aren't in the top 1,000 lexical searches results. But I can use a function that we have generated, or that we have created, sorry, called the vector score. The vector score allows us to generate a hybrid score that combines the normal CTS score with a vector distance. And we can take that, use that to calculate a final hybrid score for the document. So if I run this, now I get a hybrid score, which is a combination of the search score and the distance. And so, as I said before, this allows us to find the most relevant content by combining our lexical queries with the vector distance. And if you really were to dig through, if I pulled back a longer result set, you'd see that some of the scores coming back here would be actually would be null, because those are documents that are not in the actual lexical search, but they did match, in the top K vector distance. Just real quick, we'll bump through the sort of, obviously you should be able to access all of this stuff through SQL. If I run this query, as I said, the VPN has been acting up here a little bit. Okay, that's not, I don't know why that's not running. So this is a, we can access our virtual views via SQL. So these were the title and the text content that we pulled back from the virtual columns. Just a demonstration real quick on the using the universal index. If I go back to this one, I know that I have my title column. I have a bunch of different titles in my data set. If I want to do a query where I match that title, we know based on the TDE that view is defined as virtual, right? And so this title, we see that query ran really fast, 150 milliseconds. That's because under the covers, the query engine was able to map the TDE expression, which was the article title element. It was able to map that into a universal index lookup, and then only find the candidate documents where that element equals the value that I specified in the query. So there's lots of caveats for this, and those will be clearly documented in the feature documentation. But like, for example, if your column was a completely calculated value, right? Like some number that you combined 6 different values within the document, like we can't use the universal index to look that up, for example, right? So it's mostly useful for exact batch lookup values, but we can also leverage range indexes for range queries and order bys as well. With that, I'm going to pop back over to my slides real quick and talk about dynamic hosts. I think we're doing okay on time. I know I need to leave a few minutes for Mr. Kenwood as well. Dynamic hosts. Dynamic hosts, as Mitch mentioned, allow us to easily scale the Marklogic cluster to add more capacity for query processing. Those of you who are familiar with Marklogic operationally, right now in Marklogic 11, it's it's kind of a heavyweight process to add and remove hosts from the cluster. If you want to add a new e-node, you have to go through a fairly complex join process. It takes a little while. It actually also clears out, blows away your caches, does all kinds of things that you might not want to happen when you're trying to actually add more query capacity to your cluster. In Marklogic 12, dynamic hosts, they join the cluster using a new token-based authentication. You can enable the feature at the group level, and you also can enable the authentication at the app server level. And one of the most important aspects is that these dynamic hosts are not counted as part of your cluster quorum, right? So you could have a 3-host cluster, your data nodes, and you could have 15 dynamic hosts, and they could all go away, and they don't, count as part of the cluster quorum. So let me just show real quick here. I'm going to use Docker Compose to demonstrate this. I have a simple cluster set up with just one host called static. And yeah, in the Marklogic admin UI, you see we have basically 2 sections under the hosts list, one for static hosts and one for dynamic hosts. So I just have one host. I have a Docker Compose file here. Let me show this. I have a Docker Compose file that adds 3 new hosts, dynamic 1, 2, and 3. Oops. In the admin UI, I can go through the security settings, and there's a new section here called Cluster API Tokens. Cluster API tokens, I can go in, I can generate a new token. You can put some comment in there about why you're generating that token. The purpose is dynamic hosts. You'll see this as a dropdown with one value. The whole idea here is that we will be building on this cluster API tokens capability. Dynamic hosts are the sort of only one that we support right now. Let's generate a token. This is going to generate a JWT token that we can then, so I'll show you the purpose is it's a dynamic host. This was our comment, when it was generated, how long it's valid for, and how much time is left. And then we can copy it, we can revoke that token. If I go back into to my Docker configuration, I had an old token here I was using. I need to delete this one. Let me paste in this new token. So now if I do Docker Compose up, this is going to start up all 3 of those new hosts. And they just take a second. It's all running on my laptop. So all 3 of those hosts are ready. If I pop back over to my hosts here under dynamic hosts, I now have 3 hosts, right? So super fast. They joined into the cluster. One thing to note, as I mentioned in the slides, at the group level, right? We've enabled dynamic hosts for this group, so you can have groups within your cluster. Some of them that can allow dynamic hosts, and some of them that don't, right? I think the main sort of use case would be that you would have a group that was dedicated for your dynamic hosts and other groups for other types of hosts. And with that, I'm going to switch back to the slides and just go over one last little bit, then I'll turn it over to Mr. Kenwood. So catch-all set of advancements that we are also doing in 12. And this list is not exhaustive. There's lots of other little things that you can look forward to reading about as well. But these are some of the other sort of noteworthy mentions. For OAuth, we've added support for JWKS. This allows you to specify an endpoint for validating your JWT, your tokens. V1 documents, oddly enough, you may or may not know this, but currently in Marklogic 11, the transforms, you can't, if you're using REST transforms, you can't modify the metadata collections or permissions in those REST transforms, which you can do in, say, an MLCP transform. So we're fixing V1 documents transforms so that you can modify all of the things you would need to be able to modify within a transform. improving the type handling in the Optic engine. There was a whole bunch of improvements and changes that were done under the covers to support the whole virtual views capability. So with that, it's kind of a fire hose, but I think we have a little bit of time left. I'll turn it back over to
You hold the screen then, James, because what I'll do is I'll go through the questions first, because I think they're probably more critical than the stuff I'm going to talk to.
Okay, sure.
So let me fire off a couple of these. I think in order of logical order, starting with the RAG stuff. So the question was, how do we get the vector values?
Yeah, so yeah, it's a good question. And the so Marklogic server, the core database, is really agnostic to those, right? And our sort of bounding box is you need to pass in data that has the vectors in them. But we have a whole bunch of tooling that lives outside of Marklogic server for integrating with vector classifiers for processing the data as it comes into Marklogic. Namely, the most commonly used one now is Flux. So Flux is a powerful tool that allows you to take as input from various different sources and run it through a vector classifier to generate embeddings and store it in Marklogic.
Great. Question on the virtual views. If they're not stored, where's the cost bed? Will it require more CPU, RAM, or is it a bit slower? I think you touched on that, but maybe a bit more detail.
Yeah. So, right. So the trade-off with virtual views is it allows you to not take the resource cost hit up front, right? So, yeah, normally if with materialized views, if you define 10 columns, yeah, all of those columns are going to be, I'll take CPU and disk storage on ingest. If you really only need 5 of those columns for fast queries, and the other 5 columns are just for projection, right? You're just retrieving those values. Then those can be virtual, and yeah, they're going to take a little bit more time to fetch because it actually has to retrieve the document and project those columns out at query time. But the whole concept with virtual views is that, for the most part, they're not, they're targeted more at sort of ad hoc, long-running analytic processes, as well as data exploration, where maybe you don't know the SQL or the sort of relational views that you want to project out, and upfront you can define your views as virtual to start with, sort of use SQL to explore and work through your data and incrementally define how you want your views to be set up. So, sorry, long answer to the question. Short answer is, right, it's a trade-off between resources at ingestion time and storage versus high-speed queries.
Okay. Another sort of RAG related question, then we'll get on to the more back-end ones, is there support for MCP or Model Context Protocol provided in ML12?
So yeah, Marklogic 12 doesn't have anything built into the server specifically for MCP. It's something that we've been working on in the field, and is something that we would develop as a layer that would sit on top of Marklogic server, right? So, for example, creating an MCP container that would be able to access Marklogic as expose out Marklogic tools and data through an MCP interface. But yeah, short answer is Marklogic 12 in the core server, there isn't anything specific for MCP, but it's something we're working on at the platform level.
Okay, great. Will xQuery be upgraded to the latest version? I think this followed your comment around the JavaScript engine being updated.
Yeah, so I mean, Marklogic 12 doesn't have any updates to xQuery, but yeah, post Marklogic 12, there's a number of xQuery features in the language that we definitely are exploring, but we haven't set anything specific yet for upgrading that.
Okay. You mentioned document filter will be removed. Will there be a replacement? I think we said filters wouldn't be removed, but I'll let you.
Yeah. So that it's a little bit confusing, and we'll make sure that this is like 100% clear in the release notes. But yeah, the Marklogic has a package called document converters, right? Separate RPM that you install. That RPM includes two components. It includes the document filters, which are just a tool for processing. It supports 1,000+ binary formats. It extracts out metadata and text from all of those formats, and that is the most commonly used sort of extraction capability built into the server, targeted at sort of search applications where you just are dumping in a whole bunch of data from your share drive or whatever. The other component, though, is what's called the document conversion, right? So there's a number of APIs for converting old Microsoft Office formats like Office 2005. And those converters are focused on generating sort of renderable versions of those old document formats. So those document conversion functions, XDMP, Word convert, XDMP, Excel convert, those functions are going away in 12, but document filters are staying. And as Mitch mentioned, we're upgrading the underlying libraries and making them better.
Okay, two more quick questions. Any update on Docker images to run natively on Apple Silicon?
Yeah, so without Rosetta 2 emulation. Yeah, so separate from Marklogic 12, we are working on our support for Graviton, AWS Graviton processors, and so we continue to work on our ARM port. We're not quite there yet, but we're really close. And once we get certified on Graviton, that means we will have an ARM build, and we'd be looking at certifying that for development on the Mac processors as well.
Okay, and the last question we've got, any updates to the query console?
So from a feature perspective, there aren't many updates in Marklogic 12. There's a bunch of bug fixes and actual underlying library upgrades. So we had to upgrade the Vue libraries to move those forward. But from a feature capability, there isn't much new in Marklogic 12. It's more of a maintenance refresh. But post 12.0, there's a lot of things we're exploring, especially in the area of integrating with AI and enhancing the developer experience with Query Console.
Wonderful. Thank you, James. Rapid fire questions, but that's everything we had on there.
Great.
Very quickly from me then, the only things that I wanted to cover off was for those of you that haven't already signed up to our Marklogic community, please do so. That gives you access to all of the latest documentation. But from the community, you can also access another couple of key features. There's the PAN system that allows you to sign up for alerts and notifications, so you're aware of new documentation in the knowledge base, but also critical alerts to the platform. There's our ideas platform that allows you to submit all of these ideas and these great questions that you've got to us. And that goes directly to the PM team so they can review those and give you feedback. And our CVP, our customer validation program. If you go onto the community, there's an option there to join the CVP and you can enter your details in there. That gives you access to the very latest versions of Marklogic in development and also insight to some of the demos and features that we will be releasing. So you can go along and actually see the team in development demoing some of those features. So I'd really recommend you all take a look at that. The last thing I want to mention is just a reminder to you all that Marklogic 10 will reach retirement in March 2026. So if you have any customers still running Marklogic 10, we'd advise you to consider a plan for them to upgrade to at least Marklogic 11.3 by March 2026. Or if there are new features here in Marklogic 12 they would like, then obviously you can plan for that as well when that becomes a production release. That's
Thank
it for me,
you,
Hilde.
James. Yeah,
No worries.
great. Thanks a lot for all the presentations and information. James Kerr, when will the Marklogic 12 be released? Do you have a date or?
Yeah, I mean, we're targeting the end of this month, so we're very close.
Super, very nice. So I want to thank everybody for joining. I will be sharing a recording of this session. Please feel free to share it with your colleagues, but keep it within your company, so to say. So it will be not publicly shared, but we will share a link for you. So hopefully this has been very valuable for you, and I thank you for joining, and we'll hopefully be meeting you soon again. Thanks a lot, everybody. Have a great day.
Thank you.
Bye.
Thank you. Have a great day. Bye-bye.
Thanks.
Bye.
Bye-bye.
Bye-bye.
Thanks.
Bye.
Bye.
Thank you. Bye.